Hello, I'm Jenny Lynch, and this is the Creative Science for Kids podcast.
Hi, I'm Matilda, and today's show is all about tiny bubbles found in food.
It's time for some bubbly science with fascinating fast facts about the bubbles in food, a deep dive into chemical reactions in the kitchen that make carbon dioxide gas, a question about eating acidic foods, some history about bubbly drinks, and a fizzy lemonade recipe for you to try yourself at home. Listen up, because here come 5 fun and fascinating fast facts about bubbles in food.
Facts number 1. The food we eat is made up of chemicals.
The word chemical is often used for dangerous substances, but chemicals are all around us. Our bodies are made up of chemicals, and there are chemicals in all the food we eat. A chemical can be natural, like the fibre and nutrients in fruits and vegetables, or it can be synthetic, like artificial colours and flavours that can be found in some processed foods.
Fact number 2. The chemicals in the foods we eat can be in any of the 3 states of matter: solid, liquid, or gas.
Think about adding ice cubes to a cup and then filling the cup with fizzy drink. The ice is a solid, the drink is a liquid, and the bubbles in the drink are a type of gas. Just to clarify, by fizzy drink I mean soft drink or cool drink or soda or pop or sugary drink or whatever people call bubbly carbonated drinks wherever you happen to live.
Fact number 3. A lot of tasty solid foods contain tiny bubbles of gas that help to create the texture of the food.
The next time you bite into a big fluffy piece of bread or a crispy meringue, take a close look at the bubbles in your food. Depending on how the food was prepared, the bubbles are probably filled with either air or carbon dioxide gas.
Fact number 4. Tiny bubbles in a liquid can create a stable foam.
Whipped cream is a type of stable foam that is made by whisking air into fresh cream to create tiny bubbles of air. Frothy coffee is a stable foam made by passing hot steam through milk to create the tiny bubbles. To make meringue, egg whites are whipped to make a fluffy foam which is slowly baked to turn the foam into solid meringue, with the tiny bubbles trapped inside the crispy shell.
Fact number 5. Breads and cakes have bubbles of carbon dioxide gas.
The bubbles of carbon dioxide gas in bread are usually made by yeast. In cakes, the carbon dioxide gas is often made by a reaction involving sodium bicarbonate, otherwise known as bicarb. The bubbles of carbon dioxide gas make breads and cakes rise and give the foods a soft texture, making them easy to chew and pleasant to eat.
Let's take a deep dive into the chemical reactions that make bubbles of carbon dioxide gas.
Have you ever made a model of a volcanic eruption using a bubbly chemical reaction between bicarb and vinegar? This type of chemical reaction is called an acid-base reaction, and one of the products of the reaction is carbon dioxide gas.
Here's a tip for your next model volcano. Make sure you add a squirt of dishwashing liquid to the vinegar to make the bubbles of carbon dioxide gas last longer.
White vinegar is a solution of acetic acid in water, so that's the acid part of the acid-base reaction. Sodium bicarbonate is a type of base, and it can react with the acid in vinegar, as well as other acids that might be found in foods. Baking powder is a mixture of dry ingredients, including bicarb and an acid. When water is added to the powder, the chemicals react to produce bubbles of carbon dioxide gas, and the gas makes a cake or bread rise.
Dry baker's yeast is another ingredient that needs water to make carbon dioxide gas. Yeast is a living thing, and dry baker's yeast can be stored for a long time, as long as it is kept cool and dry.
When warm water and sugar are added to dry yeast, the yeast wakes up and starts to eat the sugar. As it gobbles up the sugar, it releases carbon dioxide gas. This gas can make bread rise at room temperature and gives baked bread a soft, fluffy texture.
Now it's time for a question. If vinegar is an acid, how can it be safe to eat?
It's certainly never safe to taste a chemical that is not a type of food, but there are a lot of everyday foods that contain acids. The vinegar you might find in your kitchen cupboard is only about 4 to 7% acetic acid, and the other 93 to 96% is plain old water. So vinegar is acidic, but the vinegar used in food won't hurt you at all if you eat it. For example, vinegar is often used as an ingredient in salad dressing or as a way of preserving vegetables, like in a jar of pickles.
Other acidic foods include lemons, oranges, pineapples, and tomatoes, which are all healthy foods to eat.
Not only is it safe to eat acidic foods, but your stomach contains some very strong acid, so a little bit of extra acid in everyday foods won't make much difference at all to your digestive system. The acid in your stomach is there to kill bacteria and to help with breaking down foods. Your stomach has a protective lining to make sure the strong gastric juices in your stomach can't cause any damage to other parts of your body. So, if you have a healthy digestive system, you can safely enjoy acidic foods.
That's good, because I love the intense taste of sour lollies.
Yes, sour lollies are usually covered in a sour-tasting mixture of acids and quite a lot of sugar. The acids in sour sweets are usually citric acid, malic acid, or tartaric acid. Just like the sour taste of acidic lemon juice, these acids will make your mouth water and your face twist in extreme ways.
We sometimes eat acids in foods, and some drinks are acidic too.
Fruit juice is often acidic, and so are fizzy drinks like soda water and soft drinks. The bubbles in fizzy drinks are made of carbon dioxide gas, and when carbon dioxide gas dissolves in water, it makes a weak acid called carbonic acid. In the 1700s, an English scientist called Joseph Priestley did a lot of experiments to learn more about gases, and one of the gases he studied was carbon dioxide gas. He did experiments with ways of dissolving carbon dioxide gas in water, or fixing the gas, as scientists called this process back then. There had already been bubbles in alcoholic drinks long before Joseph Priestley's experiments in the 1700s. For example, the bubbles in beer are made by a process called fermentation, and Priestley used the gas bubbles from beer to do some of his experiments.
Non-alcoholic bubbly water only became popular after people had learnt more about the science of gases and invented ways of bubbling carbon dioxide gas to water.
By the 1800s, soda water was becoming more popular because people like Jacob Schwepp in Switzerland started selling fizzy water in bottles. People liked the refreshing taste of soda water and enjoyed the pleasing sensation of drinking the bubbly drink. Many people believed fizzy water had health benefits, similar to drinking mineral water from natural springs. These days, fizzy drinks are often used as a special treat at celebrations, like birthday parties.
You can try making your own fizzy drink as a special treat to celebrate science. Make sure you tell an adult what you are doing first, and check you have their permission. You'll need a citrus juicer, a fresh lemon, a drinking glass, some cold water, a teaspoon, sugar, and sodium bicarbonate, otherwise known as bicarb.
Ask an adult to help you cut the lemon in half and use the citrus juicer to juice the lemon. Pour the lemon juice into the glass and add cold water until there is about the same amount of water as lemon juice in the glass. Add half a teaspoon of sugar to the glass and stir to dissolve the sugar. Rinse and dry the teaspoon, or get a clean teaspoon, and use it to add half a teaspoon of sodium bicarbonate to the glass. Your lemonade drink should start to fizz. Give it a quick stir and take a sip to test the taste. You can add a little more sugar or bicarb until you are happy with the taste and the fizziness.
If you have more lemons, you could try making more fizzy lemonade to share with your friends and family.
When bicarb is added to the lemon juice mixture, it starts a chemical reaction. Lemon juice contains citric acid, which reacts with sodium bicarbonate to make bubbles of carbon dioxide gas. The other products of the chemical reaction are water and sodium citrate. Now it's time to wash up after all that kitchen chemistry. I think I'll go and make some soapy bubbles in the sink. Thanks for listening, and remember to stay curious.
The Creative Science for Kids podcast was recorded on the traditional lands of the Bidjigal people. For more information about Creative Science Australia, visit creativescience.com.au.